Hello everyone. Today our team Krishna Prajit, Maheshri, Abhinav and Ebenezer. Today we'll be explaining how a Sudoku solver works using a backtracking algorithm. This idea comes under design and analysis of algorithms. And we chose Sudoku because it perfectly demonstrates how backtracking system explores and rejects possibility. Before we go into the actual problem, first let's understand the core idea behind the backtracking. What is backtracking? Backtracking is a step-by-step problem-solving technique where we try to solve a solution one decision at a time. But whenever we realize that a decision won't lead to a valid final answer, we undo that decision. This is called backtracking. Think of it like navigating a maze. You try a path, and if it leads to a dead end, you come back and choose a different one. Similarly, in Sudoku, we try a number in a cell, and if it leads to an impossible situation later, we remove that number and try another number. Importance of backtracking. Why is backtracking important? It's mainly because efficiency through tuning. It avoids checking every possible solution. Instead, it stops early when a wrong path is detected. It's perfect for rule-based problems. Sudoku, crosswords, timetable generation all follow strict rules. If a rule breaks, we should backtrack. And it's a foundation in computing. Backtracking concepts are used even in AI, logic programming in Prolog, and in generating combinations and permutations. So this concept is simple. Just trying and checking if the input is correct, continue if it's correct, and we should undo if it's needed. So there are real life applications of backtracking as well. Backtracking is used in many scenarios: Sudoku solving, crossword puzzle generation, maze solving, N-Queen's problem, any constraint satisfaction problem. Sudoku is a beautiful example because every step has clear rules, making it ideal for demonstrating how backtracking works. Now, Abhinav will continue.
So hi guys, myself Abhinav from the group Backtracking via Sudoku Solver. So now I'm going to explain the basic idea of Sudoku, and now let's look at how the algorithm works in code form, that is simplified Sudoku. A cell, find an empty cell board for number range 1 to 10, that is an integers. If it is valid, board cell and number. Place it right there and return to true. Find an empty cell and recurse it. If success, return true and undo the placement. Return false if it fails, and always replay the structure until the every cell is filled in the grid. The structure is short, but it performs a powerful depth first search through the Sudoku grid. So now let's go to the slide 6. Solving a Sudoku step by step. So basically, to understand it practically, imagine you have an empty cell. Choose the empty cell. Try numbers 1 to 9, that is integers. For each number, check if it follows the rules of Sudoku. If yes, temporarily place it. Move to the next empty cell. If stuck later, undo and try the next number. This continues until all the 81 cells are filled, and so repeat this cycle uh, until the total Sudoku grid is totally filled. That is 81 cells. So coming to the next track, what is backtracking basically, and what happens in the process of backtracking? So in the state and partial solution, keep your partially filled grid. At the decision, choose an empty cell, and the candidates who are playing in this are digits from 1 to 9, that doesn't break the rules via recursion method. And to the transition, place a digit and go deeper, and then recursion. At the dead end, no valid candidate, so you go back and repeat yes, keep and put an end to it. So our basic goal is that all cells are filled with valid digits, and the Sudoku grid completes with 81 cells. This turns Sudoku problem into a structured cells algorithm. So coming to the next algorithm slide, imagine the flow. Start, input the 9 to 9 Sudoku grid from 0 to 9. Find an unassigned cell, a cell that is empty. Try numbers from 1 to 9 in the empty cell. For each number, check if placing the number is safe. That is, place the number in the cell. Recursively call the solver function and if stuck, undo the placement and try next method. If all failed, print solution to the end. This guarantees that if a solution exists, backtracking will find it. Otherwise, it fails there itself. Thank you, and my friend KP is going to continue from the next slide.
Hello, I'm Krishna Prajeet. I'm going to explain how the Sudoku solver works through the code. I'm going to explain the step-by-step process of the code. And this one right here is basically we are defining the grid. To implement this code, we first represent the Sudoku as a 9 by 9 grid, usually which is a 2D array. Empty cells are represented as zeros. Here we are going to check the validity. We need a function to check if placing a number is valid or not. For this, we must ensure 3 points. Number one, the number does not already appear in the same row. Number two, the number does not appear in the same column. And number three is the number does not appear in the same 3 by 3 subgrid. Only when all these 3 points pass, the number is considered to be safe. This section is for finding the empty cells. The algorithm also requires a simple function to scan the grid and return the next empty cell, which is zero, which is represented as zero. This is where the backtracking starts its decision making. This particular function is called the backtracking function. This is the heart of the solver. It performs the recursive steps. Uh, First, it chooses an empty cell. Then it tries the digits from 1 to 9. 3, it checks the validity. 4, it places temporarily. And then it recursively tries to solve the Sudoku. And if it fails, it undoes into the previous step. This continues until either the puzzle is solved or all options are exhausted. And this here is the main function. The main function ties everything together. It loads the grid, calls the solver, and then displays the final solution. If the function is unsolvable, it reports that too. And this is our final output. Finally, we display the complete Sudoku grid. The result will be valid, fully solved puzzle. Even though backtracking checks many possibilities, it does it smartly and eliminates wrong paths early.
And now coming to time complexity, for a 9 into 9 grid, there are at most 81 cells. Each empty cell can have up to 9 possibilities. In worst case, time complexity of 0 power 9 square into 9 into n square, which is exponentially shown. And also, however, in real life, backtracking is much faster than because it avoids unnecessary paths. And now coming to space complexity, space complexity for 0 power n square is for 9 into 9 grid and as well as recursion stack. Since n is equals to 9 is a constant, this is often considered as 0 power 1 in practical DAA analysis. And now coming to strengths and weaknesses. Strengths, which is simple to implement, guaranteed to find all solutions, and works extremely well with purning. Weaknesses, worst case exponential time and heavy recursion, which needs additional optimization speed. Optimization ideas, constrained bookkeeping, which maintains set for each row, each column, each block of user digits to check candidates in 0 of 1. MRV, minimum remaining values, which always picks the empty cell with a fewest legal candidates and by reducing branching. Forward checking, when you place a digit, update a candidate sets for affected cell. If any cell loses, all candidates undo immediately so that there will not be a storage loss or something. Ordering candidates. Try digits in an order. Example least constraining first and highest last. Which is it is optional, but sometimes it is very helpful. Use bitmarks for speed and memory efficiency. in tight implementations. And that concludes our presentation on a Sudoku solver work using backtracking algorithm. Thanks for watching. Goodbye.